I will draw exactly the schematic for this connector, these two switches, and this diode. Okay. So this is the power jack. We have a coil. This is MOSFET. We have a capacitor, PF capacitor. This is the first pin of this switch. This is the second. This is the third. You see this point means this is source. These three terminals are source. We have here the gate, and these four are the drain. This is the positive pins. Okay, and this other is the negative pins. These two, because we have here two red wires and here two black wires. This is coil. Why? Because here we have L24. This is another coil. This is MOSFETs. We have here another coil. We have here two PF capacitors. This is for the charge connector. Okay. This is, as you see, the connector that is connected directly to the power jack via this cable, as you can see. Okay, so let's check this. So here, as you can see, we have here two MOSFETs or switch. Okay, we have here a PF capacitor, as you can see. Okay, we have here a PF capacitor. We have two switches. Okay, and we have a diode. So also we have here a PF capacitor. So let's check this component using the multimeter. Okay, and first, or before checking this component, let's first check the continuity between this red cables, as you see, means the high pins or the positive pins. Check the continuity between this and this. Of course, you will find a continuity between this pins and one of this or two of this. Okay, so let's check it. So always we should use the multimeter and put the multimeter to the continuity option, as you can see, and then press the power button. Okay, now let's check the continuity. So as I told you before, so we have here the positive terminal goes directly here. Okay, these two pins or two cables are connected directly to this terminal because this is positive terminal. Now let's check between this. Okay, so as you can see, these two pins are connected together. Okay, as you see. Okay, now let's put one probe here. We can't put it here or here. Okay, because also here, as you see, do you see here? We can put it also here or here. So I can simply put it here, as you see, because here between this and this, the same. This is the same pin. Also between this and this is the same pin. Okay, for me it's easy to put it here. So let's put one probe here and then go, as you see, this is we have a continuity, and then go, for example, to this switch, as you see. Okay, I have continuity here. So this is the first pin of this switch, this is the second, this is the third, this is the fourth. For the fourth, no continuity, means this is source. These three pins is the source of this MOSFET. So we have here source. Okay, and as you can see here, if you focus here, you will see I have here a point. Do you see this point? Means this is source. These three terminals are source. We have here the gate, and these four are the drain. Normally these four should be connected together. Let's check. So let's check these four pins. Okay, so let's put the probe of the multimeter in one pin and then check the second. So this is the second pin, the third pin, the fourth pin. So all these pins are connected together. Means this is drain, these three are source, and this is gate. So this, okay, the positive terminal is connected directly to the source of this MOSFET, okay, and then the drain of this MOSFET will be automatically connected here. So let's check what we have here. So if you focus also here, we have here the point. The pin number 1 is here, means this is the source. These 3 pins are source, and we have here the drain, and these 4 pins are drain. So let's check if these pins are drain or not. So let's check the continuity another time. So okay, this is 1, 2, 3, 4. So all these pins are connected together. So the drain of this MOSFET is connected to the drain of this MOSFET. Okay, and of course here we will get here a source. So this is the first pin. I have here the second pin, the third pin. Okay, here we have gate not connected to this 3 pin. So we have here drain and source. So the 19 volt or the positive terminal is connected to the source of this MOSFET, and then the drain of this MOSFET is connected to the drain of the second MOSFET, as you can see. Then here we have the source of this MOSFET will distribute the power through the whole motherboard. Okay, so let's check. As you see, let's check, for example, as you can see here, we have here a circuit. This is here, this is the power circuit. Here, this is the switches that we find near to the power jack. So here, as you see, let's assume that, for example, we have here 19 volt here. Okay, and then 19 volt goes to these pins, and then from these pins goes to the switch. Of course, this switch will be connected to this diode, as you see. This is the cathode of diode, and this, the anode, should be connected to the ground. So let's check. As you see, this is ground. I will draw for you the schematic of this circuit. Okay, so we have here 19 volt. So 19 volt goes from here directly to here, to this pin, and then from this pin, this 2 pin, goes to the source of this switch, and then to the cathode of this diode. This is a protection diode, as you can see. Okay, and the anode for this diode is automatically connected to the ground, and then the 19 volt will pass through this switch and then go to this drain, as you can see here. Okay, to this drain, and then from drain will enter in this drain of the second switch, and the 19 volt will pass through this switch to the source of the switch. Now, from this switch, as you can see, the 19 volt will be distributed to the whole motherboard, to the big or to the important circuit in the motherboard. For example, as you see, this is one circuit. This is the circuit of the processor, as you see, because we have here the fan. So the processor is in the back of this. In the back here we have the processor right in the back. So this is the processor circuit. So let's check. Normal, the 19 volt will goes from here to here. So let's check all these MOSFETs. As you can see, do you see? I have here in the multimeter 003, means this is connected directly to this MOSFET. So this source is connected directly to the drain of this MOSFET. As you see, this is the drain of this MOSFET, because here we have the gate and we have the source. Do you see? We have 3 pins connected together. Okay, and we have the drain, the gate, and here the drain. So the drain of this MOSFET is connected to the source of this MOSFET. Okay, so this MOSFET distribute the 19 volt or the power to the whole motherboard. Okay, as you can see, because here this is the first channel. Let's see another channel. So let's see here. also the same, as you see. So 19 volts, let's assume that we have here 19 volts goes here to this MOSFET and also to this MOSFET. Okay, so also let's look for another circuit. For example, in this motherboard, as you see, we have here another circuit. Do you see this circuit? Okay, always when you find a group of MOSFETs, that means this is an important circuit. Okay, circuit. So as you see, we have here the connector, okay, and here we have two switches and diode. So let's draw this. I will explain to you the schematic. In the schematic, I will draw exactly the schematic for this connector, these two switches, and this diode, okay, and the red probe in the anode, as you see, and we should get a reading, as you see, about 200 or 600, no problem. Okay, so this is a good diode. So I have here a paper, as you can see. So as you see, so I have here this, the power jack. Let's assume that this is the power jack. Let's assume that here we have the power jack here, okay, the power jack. Okay, let's just take one path. Okay, here we have 19 volts, for example. Okay, so this positive terminal will go directly, normally will go to the diode. Okay, so here we have a diode exactly like this connected to the ground. As you can see here, the anode is connected to the ground. Okay, and here, as you see, we have here 19 volts. Okay, this is the cathode of this diode. As you see, the cathode is connected to this terminal, to the positive terminal. And then here we have the first switch. Okay, we have here the first switch. This is the first switch, this switch. So here we have source, three pins or three terminals. So here we have the first, we have here the second and the third. These three pins is connected to the 9 volt, and here we have the gate. Okay, this is the gate. Here we have drain. Okay, 4 pins. As you see, these 4 pins are connected directly to another switch with its drain, as you see. Okay, this switch we have here drain. Okay, so this is drain, this is drain, this is source. And of course here we have 3 terminals that is connected together, and that gives to us the 19 volts. Okay, and here we have another gate. Okay, so do you see, this is the schematic for this. We have diode, as you see, this is diode. Okay, as you see, we have here D21, as you can see here. We have here D21. Here we have U14 for this switch, and here we have U41. So U40, U41, D20, as you see, D21 over here. This is D21. Here we have the U40, okay, and U41. Okay, so this is the power jack, the 19 volt goes. This is for the protection. This diode is for protection, as you can see here. This is for protection. Okay, exactly like the fuse. Here we have the first MOSFET, this MOSFET. Okay, as you see, the source, we have gate. The drain of this MOSFET is connected to the drain of this MOSFET, or the switch. 2 drains connected together, as you can see, and the source, we will get this 19 volt, we will get it here. Okay, will be distributed, okay, to motherboard circuit. Okay, so this circuit are the CPU circuit, GMCH and ICH circuit, the RAM, okay, circuit, the 3 volt, 5 volt circuit, etc. Okay, so this is the working principle of the power in the motherboard. This is just a part of the power circuit. Okay, so as you can see here, okay, so this is the power jack. As you can see, we have here the power jack, and of course, as you can see here, we have a coil. Okay, this is a coil. We have here L1, so means this is a coil. Okay, we have here switch or MOSFETs. This is MOSFET. We have a capacitor, PF capacitor. Okay, we have here a coil. This is a resistor, as you see, the R15. This is a current sense resistor. Okay, this is an IC. This is the IC, the charge IC. This is the charge IC. Okay, so we can check all these components, and also in the back of this power jack also you should check this diode. We have here this MOSFETs, we have another diode, we have other diode, PF capacitor. So let's check this components using the multimeter. I will show you how. So always we should put the multimeter to the buzzer option. This is a very important option in the multimeter. I like this option, the buzzer option. So let's press the power button, and then let's check the first component. Here we have a coil. Okay, so let's check first the continuity is seated correctly. So we have the coil. As you see, the coil should be, we should hear a buzzer. So the coil is good. The coil is in good state. Okay, the coil is in good state. Okay, as you can see. So here we have some PF capacitor. For the PF capacitor, you should not hear any buzzer or any continuity. If you hear a buzzer or a continuity, means the PF capacitor is bad, or the IC near to it is bad. So we have here MOSFET. We can just, here we have source and here we have drain. We can just check between drain and source. Now continuity means good. Okay, the same for this. Now continuity means good. Okay, so this is the drain, or this 3. Here we have the drain. Okay, let's check it. The first, as you see, this is the drain. 4 pins connected together. Here we have the point. As you can see here, I have the point, means this is the pin number 1, means this is the source. These 3 connectors are source, and here we have the gate. Okay, so here we have this point here, means this is the pin number 1, so this is source. These 3 pins are source. Okay, these 3 pins are source, as you can see. Okay, as you see, these 3 pins are source, and we have here the gate, and here we have drain. These 4 pins are connected together, as you can see. As you can see. Okay, so now continuity between source and drain automatically means the MOSFET is good, in good state. Okay, this is another diode, so you should look for the cathode. We have here cathode, so let's put here the black probe, and here we have anode. So let's check this resistor. This is a current sense resistor, no problem. This, you should hear a buzzer when you check this resistor using the multimeter. Also, this is a coil, so let's check this coil. Good, coil exactly like a fuse. Okay, so let's check here the back of the power jack. As you can see, we have other components, so let's check this diode. So we have the cathode is right here. Let's put the black probe here. Okay, and the red probe here. As you see, we have a reading in the multimeter, means this Zener diode is good. We have here a switch or a MOSFET. We can check it. Here we have this point over here. Okay, as you see, means this is source. These 3 are source, as you see. Okay, and here we have the drain. And of course here we have source, then here this is drain. Okay, let's check this. 4 should be connected together. Let's check. Okay, you see all these pins are connected together. So let's check between source and drain. No continuity, as you see, means this is a good MOSFET. Automatically, of course, you can check the MOSFET using the multimeter. You should check between source and drain, between source and drain, and between drain and source, and between source and gate, and also between source or between drain and gate, etc. But the fast checking for the MOSFET is between source and drain, like this. If you find a continuity, means the MOSFET is bad. If not, then the MOSFET 99% is good. Okay, so we have here another diode. So as you see, so we have here plus means the anode, and here we have cathode. Let's put the black. Always we put the black probe of the multimeter into cathode or in the minus of the diode, and the red probe in the anode, as you see, and we should get a reading, as you see, about 200 or 600, no problem. Okay, so this is a good diode. So here we have PF capacitor. The PF capacitor, you should note here in a buzzer. Okay, so all these PF capacitor are good. Okay, so as you see, we have checked about all these components, and it seems that all these components are in good state. Okay, as you see, now here we have the power jack is good, the solder of the power jack is good, these components are good. So let's check another motherboard. So as you can see here, for this motherboard, as you see, we have here the power jack, and we have here the cable right here. So here, these 2 pins, as you can see, this is the positive pins. Okay, and this other is the negative pins, these 2, because we have here 2 red wires and here 2 black wires. So we can just check this. This is coil, as you can see here. This is coil. Why? Because here we have L24. This coil should give a continuity. This is another coil. This is MOSFETs. Okay, these 2 are MOSFETs. We have here another coil. We have here 2 PF capacitors. This is for the charge connector. Okay, we can just go here also and check. As you can see here, this is a resistor, a current sense resistor. As you see, this should give a continuity. If it doesn't give a continuity or a buzzer, means it is failed. Here we have a coil. This is coil, not capacitor. Here we have MOSFET. Okay, so this is the main working principle.